The cosmos is vast, and its secrets are revealed to us one by one. For so long, we looked at the planets in our own solar system as the standard blueprint for the universe. We had small, rocky worlds like Earth and Mars, and we had giant gas planets like Jupiter and Saturn. We thought that was the whole story, but the universe is far more creative than our limited imagination. We are now discovering a whole new category of planet, one that our own solar system is missing. These are the super-Earths. They are worlds larger than our own home but smaller than the icy giant Neptune. They are a bridge between the rocky and the gaseous. These super-Earths are a fascinating puzzle. Are they just scaled-up versions of our own planet, with vast continents and deep oceans? Or are they something else entirely, perhaps water worlds with no land in sight, or planets with crushing atmospheres unlike anything we know? Early discoveries tended to find super-Earths huddled very close to their parent stars. This made sense, as our detection methods were best at finding large planets in tight, fast orbits. These hot super-Earths were intriguing, but they painted a picture of a galaxy where these worlds were rare oddities, scorched by their suns and unlikely to harbor life as we know it. We thought they were the exception, not the rule. So, for a time, we believed our solar system's layout was typical. A neat arrangement of small, rocky planets close in and giant gas planets far out. The absence of a super-Earth in our own cosmic backyard reinforced this idea. We were a model for how planetary systems formed and evolved. The data we had seemed to support this conclusion. But science is a journey of constant discovery. It is about questioning what we think we know, and being open to the possibility that we are wrong. The universe had a major surprise in store for us. One that would challenge our place in the cosmos and redefine our understanding of planetary formation. This new chapter in our cosmic story is being written right now, today, on October 7th, 2025. Recent findings from the brilliant minds at the Harvard-Smithsonian Center for Astrophysics have completely overturned our old assumptions. They have pulled back a curtain on a hidden population of worlds. It turns out that super-Earths are not rare at all. In fact, they might be the most common type of planet in our Milky Way galaxy. And most of them are not where we were looking. They are not close to their stars. They are lurking in the cold, distant outer regions of their solar systems, far from the warmth of their sun. This is a profound revelation. How did we find these hidden worlds, so far from the light of their stars? We used gravity itself as a lens. Think about this. Albert Einstein showed us that massive objects warp the fabric of spacetime, like a bowling ball on a trampoline. This warping doesn't just affect planets and moons. It also bends the path of light. This phenomenon is called gravitational lensing. When a star passes in front of another, more distant star from our point of view, its gravity can act like a magnifying glass. It briefly brightens the light of the background star. This cosmic alignment allows us to see things that would otherwise remain invisible. Now imagine that the foreground star isn't alone. Imagine it has a planet orbiting it. As the star and its planet drift across our line of sight, the planet's own gravity adds a little extra warp to spacetime. This creates a second, smaller, and much shorter spike in the light from the background star. This is gravitational microlensing. It's an incredibly precise and powerful technique. It's like finding a flea on the back of a dog that is walking in front of a distant streetlight, just by noticing a tiny flicker in the light. This method is our key to unlocking the secrets of the outer reaches of other solar systems. Unlike other planet hunting methods, which are biased toward finding big planets close to their stars, microlensing is different. It is most sensitive to planets that are at a great distance from their star, roughly where Jupiter and Saturn are in our own solar system. This is why it has been so revolutionary. It opened up a new discovery space, a new cosmic territory that was previously in shadow. The Harvard-Smithsonian team used this technique to scan the galaxy, and what they found was a treasure trove. They didn't just find one or two, they found that these cold super-Earths are everywhere. This discovery is a testament to human ingenuity. We have learned to use the fundamental laws of the universe to our advantage. We have turned gravity, the force that holds galaxies together, into a tool for exploration. We are peering into the darkness between the stars and finding new worlds. Each little flicker of light, each data point captured by our telescopes, is a message from across the galaxy. It's a whisper from a distant solar system, telling us that it exists and that it is home to planets we never knew were possible. The universe is speaking to us, and we are finally learning its language. With this flood of new data, our perspective has shifted. The neat and tidy model of our own solar system no longer seems to be the universal standard. In fact, we might be the unusual ones. The prevalence of super-Earths across the Milky Way suggests that our solar system, with its lack of a planet between the size of Earth and Neptune, is actually quite special. We are not the template, we are a variation on a theme. Most planetary systems out there might look fundamentally different from our own. This forces us to rethink everything we thought we knew about how planets are born and grow. The old theories of planet formation were built around our solar system. They explained how rocky planets formed close to the star, and how gas giants formed farther out, where it was cold enough for ice to accumulate. But they didn't naturally produce these intermediate mass super-Earths in large numbers, especially not in the cold outer regions. The new discoveries challenge these models directly. They tell us that the process of building a planetary system is more diverse and more chaotic than we ever imagined. There are forces and mechanisms at play that we are only just beginning to understand. This realization is both humbling and exhilarating. It's humbling because it reminds us that we are not the center of the universe, not in location, and perhaps not in form. The cosmos is not built in our image, but it is exhilarating because it opens up a universe of new possibilities. If super-Earths are the galactic norm, then we must ask, what are they like? They could be rocky planets with thick hydrogen atmospheres. They could be ocean worlds covered by a global sea hundreds of kilometers deep. The diversity of these worlds is likely to be staggering, far exceeding the variety we see in our own cosmic neighborhood. So, we find ourselves at a scientific crossroads. Our solar system is a single data point in a galaxy of billions. For centuries, it was our only data point. Now, thanks to techniques like gravitational microlensing, we are populating a grand chart of worlds. We are beginning to see the true breadth of what is possible. The story of our solar system is just one chapter in an epic cosmic saga, and it seems the most common protagonists in that saga are not Earth-like planets, or Jupiter-like giants, but these mysterious and abundant super-Earths, the hidden gems of the Milky Way. Whenever we discover a new class of planet, one question immediately ignites our imagination. Could there be life? The discovery that super-Earths are common, especially in stable, distant orbits, reframes this ancient question. While these cold super-Earths are far from their star's traditional habitable zone where liquid water could exist on the surface, life might be more resourceful than that. A super-Earth with a thick atmosphere of hydrogen could act like a planetary blanket, trapping enough internal heat to keep water liquid on its surface, even in the deep freeze of interstellar space. Life could exist in ways we haven't even dreamed of yet. This idea expands our vision for where to look for life. We don't have to limit our search to Earth-like clones orbiting sun-like stars. Life might be thriving in the deep, dark oceans of a water world, warmed not by a star, but by the planet's own geothermal heart. It could be floating in the dense atmosphere of a world with no surface at all. These super-Earths offer a whole new suite of potential habitats, a new set of environmental conditions where the chemistry of life could take hold. The universe, it seems, has a much broader imagination for creating living worlds than we do. This is what makes science so powerful. It is a tool for wonder. Each discovery does not simply answer a question. It reveals a dozen more, each more profound than the last. We started by asking if there were other planets. We found them. We asked what they were like. We found they were more varied than we could have guessed. Now we ask if these common super-Earths could harbor life. The answer is still out there, waiting for us in the starlight. The quest to find it will drive us to build new telescopes, to devise new methods, and to push the boundaries of our knowledge ever further. Look up at the night sky. That river of light, the Milky Way, is not just a collection of distant suns. It is a sea of possibilities. It is teeming with worlds. We now know that many of them are super-Earths, orbiting silently in the dark. What secrets do they hold? What wonders await us? We are explorers on the shore of a cosmic ocean, and we have just dipped our toes in the water. The journey ahead is long, but the motivation is simple and profound. The need to know, to understand, and to see what lies over the next horizon. The cosmos awaits.